Hi, welcome back to my channel. So today we'll discuss about the industry related interview questions on FEA, finite element analysis, and question with answers are provided here. So let's discuss what are the questions they ask in the interviews. So one is what is finite element analysis, which is FEA. Is a numerical method to approximate the solutions of complex engineering problems by discretizing a structure into finite element and solving governing equation. Second question is why is discretization required? Because the real structures has infinite degrees of freedom. So discretization converts them into solvable finite system. So what are degree of freedom? DOF. It's independent displacement components at the node. Example, UX, UY and UZ and the rotation. So it means the translation and the rotation. So that we called the degree of freedom in all three directions. So what governing equations in FEA? What governs the accuracy in FEA? So the answer is the quality of mesh, the boundary condition, material model, load representation. The accuracy in engineering assumption depends. So whatever the assumption we are doing, it depends on the accuracy, not the solver dependent. So the next question is what is stiffness matrix? The matrix relating the nodal forces to nodal displacement. K is the stiffness, U is the displacement, and F is the force. So nodal force. So this is called the stiffness matrix. The next question is the difference between displacement and the force formulation. The most commercial FEA uses displacement based formulation. Next question is what are primary and secondary variables? The primary variable is displacement, the secondary is strain, stress, which is derived variables. So eighth question is why are stresses less accurate than the displacement? Because the stresses are derived from the displacement gradient. That's why it is less accurate. This is the most uh, popular question. So what is shell versus solid elements? When to use shell and when to use solid? So the shell we use when we have a thin structure where the instruction is less than the length we are taking. The solid we use when we have a thick components, like when it has a 3D stress state. So next question is when do you use beam element? When we have a slender structures where bending is dominant, in that case we use the beam elements. So this is also very uh, important question when to use hex elements and tet elements. So the hex elements when we want a very high accuracy per degree of freedom we use hex. In tet we use easier meshing for complex geometry, we use tet elements. So quadratic tets are acceptable. So again here the linear and quadratic are there. So for convergence and all we use the quadratic tets are acceptable with the convergence proof. So what is mesh convergence? So this is also very uh, important question. So when further mesh refinement does not significantly change the result, that's we called mesh convergence. When we want to define what is the element size and all, so before standardizing the element size and all, we need to do the mesh convergence study. So in that case, so where the results won't change significantly, then we call it as mesh convergence. What is aspect ratio? The ratio of longest to shortest element dimension. So high values reduce the accuracy. What is Jacobian in FEA? It measures the element distortion. Should be positive and close to 1. It should not be negative. If it is negative Jacobian, throw the error. So we have to fix that. What is hourglassing? Zero energy deformation mode in reduced integration elements. How do you define mesh effectively? Refine the mesh effectively. So answer is when we have a local refinement like near the stress concentration region and the load applications and interfaces and all. So we need to have a refined mesh. Why are boundary condition critical? Uh, the wrong BCs like wrong boundary condition produce the physical meaningless results. So it is the results are worse than the coarse mesh. That's why we need to very much focused on the BCs. So we should give very right BCs to get very good results. So fully fixed BC, good or bad? Uh, so only if physical justified, only if physically justified, otherwise it's artificially stiffen the models. How do you prevent rigid body motion? Apply some minimum constraint to restrain all degree of freedoms without over constraining. How do you apply realistic loads? Uh, so realistic loads, the answer is the pressure instead of force, distributed loads, remote forces or coupling elements. Why check the reaction force? Why we have to check the reaction force? They verify the load balance and the BC correctness. Like first, before going to any other analysis, first we have to check the reaction forces just to check whether we are getting correct. We have applied the correct BCs and the load is actually balancing. So before doing that, we have to do this reaction force check. Why is symmetry BCs? Constrained exploding geometric and load symmetry to reduce the model size. What is over constraint? Applying more constraint than required is called over constraint and that leads to artificial stresses. What is load path? So load path in the sense like how the forces are traveling through the structure to supports, that we call it as the load path. So next question is what makes a problem non-linear? So when we talk about the non-linearity, there are three different non-linearities. One is material non-linearity, geometric non-linearity, and contact non-linearity. So when we have this, the problem is non-linear, then we have to use appropriate BCs. And next question is what is small and large deformation? Large deformation affects the stiffness and the loading direction. We have very large deformation, the stiffness will change and the loading path will change. What is plasticity? Permanent deformation after heat we call it as plasticity. Elastic perfectly plastic versus hardening. So if you take perfectly plastic means there is no stiffness after heat. Hardening means increasing the resistance. What is convergence in nonlinear analysis? The answer is satisfaction of equilibrium within the tolerance. What is force versus displacement control? The displacement control improves convergence in unstable problem. So we have heard about what is Newton-Raphson method. It's a iterative method to solve the nonlinear equilibrium equations. So why nonlinear analysis fails? Because of poor contact setups, large load steps, bad mesh quality. Because of that nonlinear analysis fails. What is contact analysis? Simulation of interaction between the bodies, allowing separation or slidings. Bond versus frictional contacts. What is bond? What is bonded contact and frictional contact? Bonded contact means there is no separation between the two component, and if you take frictional, there is sliding with assistance. And there, we also heard about the penalty method and leveraging method. What is the difference is, in penalty it allows the penetration, in leveraging it restricts the constraints. So why to start with frictionless contact? So in order to improve the convergence and isolates the contact behavior, first we have to start with contactless, frictionless contacts. Then we can apply whatever the context is appropriate. What causes contact non-convergence? So that leads to effective stiffness, poor initial contact detection. What is contact stiffness tuning? So contact stiffness tuning in the sense we are going to adjust the penalty stiffness for stability and the accuracy. What is in fatigue? This is a common question they ask. What is stress life versus strain life type of fatigue? So in high cycle fatigue, we observed the stress life approach. In low cycle fatigue, it's a strain based approach. So what is mean stress correction models? So what models we use to do the mean stress corrections? There are three models. One is Goodman, Gerber, and SWT. What do FEA provides in fatigue? So the input what we give is stress and strain input, not life directly, because life will not give in FEA we won't get the life, but we'll get the stress strain response. What is creep? Creep is a time dependent deformation under constant stress at high temperature. What is stress relaxation? It's reduction in stress under constant strain. Why thermal analysis coupled? Thermal effects. Temperature affects material property and expansion. What is thermal strain? The strain caused by temperature change without stress. How do you validate FEA model? So how do you validate FEA model? Comparing the stiffness, deformation shape, and failure location with test. So this is how we validate the FEA model is correct or not. Acceptability test versus FEA derivations. So 10 to 20% depends on the variability and the assumptions. The peak stress trust or not. Only if the mesh converge and physically meaningful, then we can trust the peak stress. Tool user versus analysis. So analyst what they does is they understand the physics of the problem and the assumptions and the limitations, whereas the tool user they just know how to use the tool, but they don't know the physics of the problem. So one sentence philosophy of FEA. So FEA supports engineering judgments. It does not replace it. So these are some of the questions they may ask in the interview. So this will be helpful for freshers who are going to crack an interview in corporate or in any entrance exams or in interviews for the courses. So there are some more questions. I'll just post it in the next slides. But the important one and the basic one I just captured and put it in the slides. Please go through it, and if you need any more interview questions, comment below. So we'll make those slides and post it in the coming slides. Thank you so much.